Once if we map the K-map for the given function, next step is what we have learned in SOP is we have to find out or we have to mark the pair, quad and as well as octet. 13, 15 and 11 and 9 it forms, there are 4 continuous ones, maybe in rows as well as in column. So this can also form one quad here. That is the second quad. The variable D changing its states from D to D0, that has to be eliminated. Dear students, welcome to CS classes. I am Ravi Kumar KR, lecturer in computer science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, in this session, we are going to discuss about the simplification of Boolean equation using K-map. Now, product of sum reduction using K-map. Students, in our previous session, we were discussing about the reduction of Boolean equation using SOP form or sum of product form. So, but in this session, now we will discuss about how to solve the Boolean equation or how to reduce Boolean equation using POS form or product of sum form. So here, now for POS reduction map is filled by placing zeros in squares whose max term lead to output 0. Here in SOP form, we used to fill the place with 1 because in SOP we used to consider min term. So value of variable x equals to 1. Now in POS form, we have to consider the max term. Here we represent max term with capital letter M and value of variable x equals to 0. So we have to fill the squares with 0. That is the one difference between SOP and POS. And look at the example here. This is 2 variable K-map and here. Now at this stage you know how to draw K-map here. Here it depends on number of variables. If there are 2 variables, there are 4 squares. If there are 3 variables, 2 to the power of 3 that is equal to 8. There are 8 squares. And if there are 4 variables K-map and it will be having 2 to the power of 4 that is equals 16. 16 squares should be there in your K-map. Now let us see the example of this. How to draw 2 variable K-map for POS reduction. In this example, this is the K-map, 2 variable K-map and numbering scheme is remain same as what you have learned in SOP form. So here 0, 1, 2, 3 is a numbering scheme and here the variables and here please understand this is decimal 0 and binary equivalent of this will be 0, 0, 0, 1 and here 1, 0 and 1, 1. That is how we have to fill the details here. The binary equivalent of decimal 0 is 0, 0 and this is 0, 1 and it is 1, 0 and it is 1, 1. So accordingly we have to write the variables here. So if it is 0 means variable value of variable x equal to 0 in max term, it is x and this is y here. And here we are using plus in between. So this is x plus y. So if you look at it is x plus y naught because it is 0, 1. So here y naught and this is 1, 0, x naught plus y. And for 1, 1, it is x naught plus y naught. So accordingly, we have to write the variables for rows as well as columns. For this, it is x and it is x naught, y, y naught. So you can also make out x in this address of this would be x plus y naught, x naught plus y and this is x naught plus y naught. So this is how to write the variables for the given K-map in POS form. Now let us see this 3 variable K-map, 2 to the power of 3 that is equal to 8 squares with 2 rows and 4 columns. And numbering scheme is 0, 1, 2, 3, 4, 5, 6, 7. So accordingly, we have to write the variables here. And this is decimal number 0, and the binary equivalent will be as we have seen in the previous example here in the previous slide. So this is how to first we have to write the binary equivalent. So if you write the binary equivalent, it is easy for us to write the variables here by looking at the values. So accordingly, this variable, so this K-map, we have to write the variables for rows as well as columns. So here x and x0 are the variables here, and it is y and z are here. So there are three variables. Rows we have only one variable x, and for columns we are using y and z. So this is the three variable K-map for PUC form. Now let us look into the four variable K-map. Here 4, 2 to the power of 4, that is 16 squares with 4 rows and 4 columns, and numbering scheme is same. It is 0, 1, 2, 3, 4, 5, 6, 7, and here 8, 9, 10, 11, 12, 13, 14 and 15. Next, we have to write the variables for this K-map for rows as well as for columns. Here rows, please understand here there are two variables here. It is w plus x, and here variables, two variables, that is y plus z here. So here w plus x, w plus x naught, w naught x naught, and w naught plus x for rows, and for columns y plus z, y z naught, y naught plus z naught, and it is y naught plus z. Hope you know how to write the variables for the given K-map, whether it is a 2 variable, 3 variable or 4 variable K-maps. So this is the first step. Next one is how do we solve it? By using PUC form. So first step is we have to write the K-map for the given number of variables along with the variables in rows as well as for columns. Next one is how to derive PUC expression using K-map. First, rules of deriving expression are the same except for the thing PUC expression adjacent to zeros are encircled in the form of pairs, quads and octets. Therefore, rules for deriving PUC Boolean expression can be summarized as follows. Once if we map the K-map for the given function, next step is what we have learned in SOP is we have to find out or we have to mark the pair, quad and as well as octet. Same rules holds good even for this PUC form here. So first step is prepare the truth table for the given function, then draw an empty K-map for the given function, whether it is a 2 variable, 3 or 4 variable. Next, map the given function n by entering zeros here. In SOP form, we used to map it with the number or digit 1, but here we have to enter 0 for the values given in the function, Boolean function. Next, for rest of the squares or for the blank squares that has to be filled with ones. Next, encircle adjacent zeros in the form of octets, quads and pair. As usually, how we have done it, how we have marked in SOP form, similarly, by following the same rules, we have to mark the pair, then quad and octets. So those rules holds good even for PUC form. Next one, remove the redundant groups if any. See, these are all the rules already we have learned in our previous session for reducing reducing Boolean equation by SOP form. Now let us see one example how to solve it, how to solve the given equation by using K-map. Now, the first example is the given function is f of ABCD equals sigma 7, 9, 10, 11, 12, 13, 14, 15. This is the function given. So we have to express the given function in reduced form of SOP form. Now, by looking at the symbol here sigma, this sigma represent it as SOP form. So this is a function with SOP form. So we have to solve this by using SOP form. So first we have to draw the K-map. Here they have given 4 variables A, B, C, D. So 4 variables, 2 to the power of 4, that is equal to 16. So we have to draw 15 squares or K-map with 15 squares, and numbering scheme as usual. Next we have to fill these values. Now look at the example here. In this is M7 is the minterm of M, it stands for M7. Here 7 is the number. So for 7, 9, 7A we marked with 1. Next one is 9, 10, 11, 12. So this is 9 and 10, 11, 12. Then 13, 14, 15. So where is 13 here? 13 and 14 and 15. So first step is we have to map in K-map. Next one is, as what you have learned already, we have to look for pair, quad and octets. Now by looking at this, after marking this and rest of the boxes, we have to fill with 0. Now look at the example here. Now once if you look at the example here, now by looking at this, we can make out here there are 4 ones, adjacent ones are there in the K-map. So this we can mark it as quad. So there is one quad here. That is the possible. Next one is, if you consider these 4 here, 13, 15 and 11 and 9, it forms, there are 4 continuous ones, maybe in rows as well as in column. So this can also form one quad here. That is the second quad. Next again you consider this. One more here, there are 2 ones here. These things we have not marked yet. So 15, M15, M14, M11 and M10. It forms one more quad. It forms one more quad here. Then after that, here we are left with this one. So this one we can make it as a pair with M7 and M15. So while after mapping in K-map for the given function, now in this example, we could able to find there are 1, 2, 3. There are 3 quads and 1 pair. This is 1 pair. That we have to mark it first. Now look at the example here. So as I told you just now, say we could able to find pair 1, quad 2 and quad 3. Now look at how do we simplify this. Now pair reduction rule. The pair removes only one variable. So look at this M7 and M15. M7 and M15. M7 and M15. If you look into that, this C and D, this is the same column, it remains same. But if you look at the row here, A0B and AB, here these 2 are ones in a pair. If you look at A0B and AB, from here to here, there is a change in the variable A from A0 to A. So this variable has to be eliminated. That can be removed. So we are left with B. So the reduction of pair for this will be the result. It results into B and CD. And after reduction of a pair, we are left with the variables B, C, D. So this is the result of reduction of pair. Now we move on to quad 1, that is M12, M13, M14, M15. Here this is 12, 13, 14 and 15. That is in a single row, third row. There are 4 adjacent ones, so it forms one quad. Now how do we simplify it? As we have learned in previous session, quad removes 2 variables. So accordingly, these all ones are in the same row, so there won't be change in variable AB. So now consider the columns here for all the ones here. Now if you look at this here, C0, D0 and here C0, D. So in this example, D change its states from D0 to D. So that variable has to be removed or it can be eliminated. Now look at from here to here. From here to here, C0, D and here C, D. Again, the variable C0 is changed its states from C0 to C. So again, that variable C can be removed. So in this, if you look at the column wise, variable C and D are change its states. So both the variables can be removed. So we are left with only variable A and B. So A and AB, that will be the result of reducing quad, or after reducing quad we are left with the variable A and B. This is the answer. Next one is, look at quad 2, that is M13, M15, M9 and M11. 13, 15, 9 and 11. Now we are considering these 4 ones. Again, this forms a quad here. Again, quad removes 2 variables. Now these numbers are both in a column as well as rows here. Now consider this row here, these rows here, AB and AB naught. So here A remains same, but B change its states from B to B naught, so B has to be removed. Now consider column here, these 2 columns here. In this column, C0D and CD. In this example, the C changes its states from C0 to C, so that variable has to be removed. So finally, we are left with AD. This is the after reduction of quad 2, the result will be AD. Now again consider one more quad, that is quad 3, M15, 11, 14, 10. Now it is 15, 11, 14 and 10. Now we are concentrating on this quad 3. Again, it removes 2 variables. Accordingly, by following the same principle, here we are left with 2 variables AC. So now, if you observe this K map here, we have marked with the 1 for the given values in the function, and we have to make sure that none of the variables, none of the values 1 should be left blank. So it has to be marked with any of the group. Either it has to be in a quad or pair or in octet. So we are not supposed to leave it any of the values of 1, any values 1 in the K map as free, or it should be marked, or it should go with any of the group. So after simplifying this, so these are the results of quad and pairs. So we have to write all this together. So the final reduced expression will be this BCD. This is the BCD plus AB plus AD plus AC. This is the final reduced expression for the given function f of ABCD equals this one. So this is how to reduce the given equation in SOP form. Students, now we look at one more example. Find the minimum POS expression of the function. The given function is y of ABCD equals pi. This pi, if there is a pi in the equation, so we have to simplify the equation using POS form, and in POS form we are considering value of max term, the value of variable in max term, that is equals to 0. Now this again 4 variable K map and 16 squares numbered, and here we have, in this example, we have to mark this given value in the function with 0. So here the 0, 1, 3, 5, 6, 7, 10, 14, 15. Accordingly, these are marked with zeros. Next one is, and for rest of the squares, that has to be filled with value 1. So this is mapping in K-map for the given function. Now let us simplify it by marking different groups here. Now by looking at this K-map here, now we have to consider the value 0. By looking at the 0 here, it is possible to have one pair here, that is M0 and M1. M0 and M1 is one pair, and here this M1, M3, M5, M7, it forms one quad here, and again this is M7, M6, M15 and M14, is one more quad here, and again we are left with this 0. So this M10 plus M14 forms one more pair here. So according to this K-map here, so we could able to find there are 2 pairs and 2 quads. 2 pairs and 2 quads. Now let us simplify this. Now pair 1 is M0, M1. Please observe this. This in POS form, we are representing the max term with the variable M, that is capital letter M, and suffix will be the values. Now let us see how to simplify these groups. Pair 1 is M0 and M1. In M0 and M1, again pair removes only one variable and it is a row A plus B, though there won't be any changes in the value variables A plus B. Now consider these 2 columns, here C plus D and here C plus D naught. So the variable D changing its states from D to D naught, that has to be eliminated. So we are left with the variable A, B, C. So we have to put it as A plus B plus C. See, this is in max term or POS form. Next, look at the pair 2, M14 and M10. M14 and M10, here this is the pair and there won't be any change in the column C0 plus D. So, because these 2 zeros on different rows, now consider these 2 rows here and observe this A0 plus B0 and here A0 plus B. In this example, B changing its status from B0 to B. So, this has to be eliminated. So, we are left with the variables A, C and D. So, that would be now, this is in the example. After reduction of pair, we are left with the variables A0 plus C0 plus D. This is a max term. Next one is quad 1. M1, M3, M5, M7. Here M1, M3, M5, M7. Consider this quad here. And in the quad here, there are these all 4s are in 2 different columns and 2 different rows. So now let us consider this row here. From here to here, A plus B, A plus B naught. So B is changing its states, that has to be eliminated. And if you look at the columns, these 2 columns here, C plus D naught and here C naught plus D naught. So in this example, C is changing its states. So that has to be eliminated. So accordingly, we are left with A plus D naught. Now, one more, this is quad 2. Consider these quad 2. In this example, it is M7, M6, M15 and M14. Again, consider 2 rows and these 2 columns. In the 2 rows, A plus B naught and here A naught plus B, A has to be eliminated. And in these columns, C0 plus D naught, C0 plus D, D has to be eliminated. So after this, so we are left with the variables B0 plus C0. This is max term expression. At last, the final expression would be y of ABCD equals here first term, that is max term A plus B plus C dot or into A0 plus C0 plus D, and it is A plus D naught and here B naught plus C naught. So this will be the final reduction expression for the given function by using POS form. Thank you very much.